Hey there, welcome back to the channel. Today we are going to solve another LeetCode problem, that is search in rotated sorted array. So there is an integer array nums sorted in ascending order with distinct values, and prior to being passed to your function, nums is possibly rotated at an unknown pivot index k, such that the resulting array is something like this. For example, 0, 1, 2, 4, 5, 6, 7 is an array, and this might be rotated at pivot index 3. And it will become 4, 5, 6, 7, 0, 1, 2. And we are given the array nums after the possible rotation and an integer target. We need to return the index of target if it is in nums, or -1 if it is not in the nums. And we have to write an algorithm that runs on logn runtime complexity. So let's see how can we approach this problem. So in this problem we are given an array of integers. Let's say array is 0, 1, 2 and 3. This array is rotated 0 times. If we rotate this array one time, then we will get 1, 2, 3 and 0. If this is rotated one time. If it is rotated two times, then we will get 2, 3, 0, 1. If it is rotated two times. So if we rotate this array one time, we get this array. If we rotate this two times, we get this array. Now in this problem, we are given the sorted rotated array. So let's say we are given another array 5, 6, 7, 0, 2, 3, and the target value is, let's say, 7. Now we have to return the index of our target 7 if the target exists. If the target does not exist, we have to return -1. So we can see this target exists in this array. So index of 7 is 0, 1, 2, 4, 5. So index of 7 is 2. So if you are given target, so we have to return this 2. And let's see, we are given the target equals to 8. Then in this array we do not have 8. So in that case we will return -1. This is the problem. Now let's see how to solve this problem. We can solve this problem pretty easily by scanning the array from left to right, and we can compare the every element with the target, and if we find out, then we can return the index of that element. If we do not find the element in the array, then we can return -1. So this will take time complexity of O of n, which is linear search algorithm. But our caution says that we have to solve this problem in the logarithmic time complexity. We have to solve in log n time complexity. So when we have to solve any problem in log n time complexity, we have to use binary search algorithm. And we know binary search only work for sorted array. But this array is sorted and rotated. So can we use the binary search algorithm here? So the answer is we cannot use binary search algorithm directly, but we have to use the modified way. So we can solve this. So we can solve this problem by modified binary search algorithm. Now let's see how to solve this problem using modified binary search algorithm. Let's assume we are given this array of integer and the target value is 4. We have to check, does the target exist in our array? If target exists, we have to return the index of the target. Otherwise, we have to return -1. So we can see that target exists in the array. So index of 4 is 8. So let's see how to find this. So first, what we will do is we'll use the modified binary search algorithm. So we are pointing the first element with the left and the last element as right. Now let's find out the middle. Middle equals to left plus right by 2, that is 0 plus 9 divided by 2, that is 4. So this is our middle. Now we need to check, does our middle equals to target? The answer is no. Now I'm going to find out the sorted portion of this array, since array is sorted and rotated. So we have to check at least one of the part from left to mid or from mid to right. Which one is sorted? Since the array is sorted and rotated, so we have at least one portion of this array which is sorted from left to middle or from mid to right. We can check that by comparing the left element and the middle element. If we saw the left element is less than the middle, that means it is sorted, but in this case it is not. And here we see this part is sorted. 0 is less than 5. So we find out a sorted part from mid to right. So what we are going to do, we are going to check, does this target lies in this mid to right portion? So we have minimum in this portion 0 and maximum 5. This is minimum and this is maximum. Does 4 goes in between these? Answer is yes, it can goes. So let's discard the left portion of this array. And now let's move the left to the mid plus 1. So now our array will become like this. 1, 2, 3, 4, 5. Where the 1 will be having the left pointer and 5 will be having the right pointer, and the middle will goes to this. Does middle equals to target? The answer is no. Now we need to again find the sorted part from left to mid and then mid to right. So first we will compare left to middle. So yes, this is sorted and this part is also sorted, but we will go for the left one. So does the 4 goes in this range? The minimum is 1 and the maximum is 3. Answer is no. It does not go in between these. So what I'm going to do, I'm going to move the left to mid plus 1. Left equals to mid plus 1. So let's discard this part. Now the array becomes is 4 and 5. 4 is having our left pointer, 5 is having our right pointer. Now the middle will become is this one. Mid equals to target, answer is yes. So we will return the index of this 4, that is 8. So we will return this 8. This is how modified binary search algorithm work. Let's take another example with a different target. And let's say target value is 8. Now let's initialize left pointer to the first element and right pointer to the last element. Let's find out the middle. So this is going to be our mid. Does middle equals to target? Answer is no. Then we need to check the sorted portion. So this portion is sorted from mid to right. What I'm going to do now is I'm going to check, does 8 fit in this sorted portion? The minimum is 0, the maximum is 5. So 8 cannot fit in this range. So what I'm going to do is I'm going to discard this portion. And I'm going to shift the right to the mid minus 1. So now the middle will be left plus right divided by 2. So this will be our mid element now. So does 7 mid equals to target? The answer is no. Now we need to check the sorted portion from left to mid. So it is a sorted portion. Answer is yes. So does 8 lie in this range? The answer is no, because minimum value is 6 and maximum is 7. So let's discard this portion as well. Now the left will come to mid plus 1. And we have right element at 9th. Now let's calculate the middle. Our middle will come to this. Now we need to check, does mid equals to target? The answer is yes. So that is how modified binary search algorithm works. We'll keep running our loop while left is less than equals to right. If this condition break and we do not find out target, then in this case we'll return -1. Let's say we are having a target as 12. So in this array we do not have 12. So in that case it will return -1. So this modified binary search algorithm takes logn time complexity. because we are dividing the array into two halves. So the time complexity is logn and the space complexity for this is O of 1. So now let's write the code for this algorithm. So first we will be having the left pointer. So int left, which is at 0 position, then int right, which is nums dot length minus 1, which is at the last of the array. Now we will run the while loop while left is less than equals to right. Now let's find out the mid. Int mid equals to left plus right minus left divided by 2. Now let's check here the middle. If nums of mid equals to target, then we will reach the index of middle element and we will return mid. If the target is not middle, then in that case what I'm going to do, I'm going to check our sorted portion. So if nums left is less than equals to nums mid, if this condition is true, it means that left to mid part is sorted. This one is left to right portion is sorted. Then what I'm going to do is I'm going to check if the target exists in this or not. So if nums of left is less than equals to target and target is less than nums of mid. So if this is true, that means the target exists from left to middle. So in that case, I'm going to shift right to middle minus 1. Otherwise, I'm going to shift left to mid plus 1. And if our left to mid is not sorted, then in that case, mid to right is sorted. And inside that, I'm going to check if target exists from mid to right. And the target is less than equals to nums dot right. So if this condition is true, that means that our target exists in this from mid to right. We have to shift our left to mid plus 1. Otherwise, we'll shift our right to mid minus 1. This is our modified binary search algorithm. And at the end, we will return minus 1. And if a statement never executed, it means that our target does not exist in the array. So in that case, it will return minus 1. The time complexity for this is O of logn and space complexity is O of 1. Now let's run this code. So our test cases are accepted. Let me run this code. So our code is accepted successfully. So I hope you found this video useful. In case you have any doubt, you can ask me in the comment section. And if you like this video, please subscribe to my channel. Thank you. I'll see you in the next one. Bye.